we have Australian standards, but they don't really say a lot about rainwater harvesting. They're more talking about, is the storage made properly?
Hmm.
Is the um, provided you do certain things, rainwater is considered in Australian standards to be low hazard. The utilities like to see it as, call it high hazard because it's a competing water source, but it's accepted as low hazard. Our Australian standards don't permit people to add chlorine to their water storages, which has just been changed recently because of what I talked about earlier. It's really a poison. Um, so they're really not talking about measurement. They're talking about getting the right sort of design in place. And they
Hmm.
also recommend regular inspections of your rainwater harvesting system to make sure the water's clear and it doesn't smell. Um, maintaining your leaf diverters and things like that. So they don't have these prescriptive tables of numbers because we've found that doesn't work.
Well, and would you say people are in general good stewards of their household rainwater systems?
Well, they've been
Um,
running for 100 years and people aren't sick. There's because there's more and more of them now in urban areas. The utility forum tries to say because they're not managed in the same way you would manage a utility treatment plant, therefore they're not managed and um, they can't be working. But our Australian standards say that more than 70% of people with rainwater harvesting systems in Australia maintain them and keep them operating. So um, they're generally well looked after. Like anything, there's a fringe group that may not be looking after as much as possible. But what we actually found out with rainwater harvesting, once you get the design right, the best way to keep it operating is not to fiddle with it, not to tinker with it, leave it alone. Um, because if you muck around with it, you're actually changing the performance of your natural treatment train. So that um, that's um, the opposite to say people running water utilities who are tinkering every day with adding all these chemicals and all this stuff into water treatment. Therefore, they perceive that you've got to be, maintaining it every day. A successful rainwater harvesting system, you leave it alone and let it operate, but keep a watching eye on it to make sure it's okay. So,
well, pretend I'm a drop of water and take me through your personal, household rainwater harvesting systems, and walk me through all the different um, components or all the different things that would happen to that drop right through to the different places where you might use that water. What's
so,
happening? What components are there?
so this is fun. We should make an animation of this one day, Michelle. So I drop. My house is in the my city house is in the inner city of the docks in a place called Carrington. So it's a docklands industrial area around it, but now an inner city urban area as well. So the particles, drops of rain, pass through the atmosphere, and they may pick up um, materials in the atmosphere, and what we've found, the atmosphere will have some bacteria in it, some other physical materials, lands on my roof, which may have deposition of bacteria and debris on it, and those debris and materials might have blown off too, and so that's an interesting process. And as other drops fall with it, it creates a critical mass and runs down my roof surface into my roof gutter. So meets my roof gutter, um, and then more drops add together till there's a critical mass in the roof gutter, and then it flows through the roof gutter and down my downpipe. Then, as those drops of water are flowing down the downpipe, it hits my leaf diverter. So my leaf diverter's got a diagonal mesh screen in there, and a horizontal fine mesh screen below it before the water continues down through the downpipe. So what that actually does is um, rainwater doesn't flow in a jet in a downpipe. It flows in a circular motion around the outside, and a lot of people don't realize that. A lot of standards for hydraulic design of rainwater harvesting systems assume a jet. There's no jet. There's a spiral of water around the outside. So when that water in that spiral hits this 45-degree angled mesh, it actually is a sudden change of the momentum in the water. So the water is in this spiral, hits that, it changes its flows, and then it drops through from that mesh onto the fine screen underneath. What changing the way the water flows through that leaf diverter not only physically traps leaves and debris, which is the major source of problem in rainwater harvesting, but it also drops out sediments into the fine screen below because they're changing the energy in the water by making it hit this screen. So it's a beautiful thing. It's simple, but there's some wonderful science behind it. So that flow, those drops of water then continue flowing down the downpipe till they hit the entry to my rainwater storage. But those drops are no longer carrying debris, and they've lost a lot of their bacteria and fine sediment that may be in them as well, because bacteria attaches itself to fine sediment. So it's about the different charges in different organic and inorganic materials. So if you're a physicist, 3 electrons. So the bacteria attaches itself to sediments, they drop out. So by the time we're actually falling into my rainwater storage, in my rainwater storage, there's mesh screens that are very fine because I don't want anything, including mosquitoes, to crawl in or fly in into my rainwater storage. So simple, part of the treatment train. So it flows through that. So the flow process has changed as it's passing through that screen as well. So it's another intersection. So then the drop hits the water surface. At the rainwater surface is what's known as a water surface microlayer. So if you're an engineer, you would know that as, or a physicist, you'd know that as the skin friction zone. If you're a microbiologist, you'd know that as the warm layer with the most access to oxygen. A medical scientist discovered this and published it in the Lancet in about 1906, I think. So it's a long time ago. So at that level, say bacteria, for instance, very fragile bacteria that needs to have oxygen and warmth, like Campylobacter or Legionella, in the unlikely event it's in your water, gets trapped at that surface layer. So eventually the drops mix into the rest of the storage because, like James Bond, his martinis, your rainwater storage is actually gently stirred because you're using the water every so often, and all through a day, your temperature changes slightly. It means it's slowly rotating. So it's a perfect bioreactor. So in that water column underneath that surface where other stuff has been trapped, that drop is either, if it's still got sediments in it, it's falling right to the bottom. So it leaves the sediments in the bottom, which is a sludge, but it's also a biofilm. Or is it passing through the water column because there's a biofilm that you can't see, usually on the walls of the storage as well. And the rainwater is stored rainwater is a low nutrient environment, and the biofilms are really hungry. They're actually stripping out organic and inorganic materials to feed the biofilm. So as the drop passes through that, in my storage, the inlet is at the opposite end to the pump for good reason. So if there's any build up in the bottom of my storage, it's at the opposite end to where I'm drawing the water out for water supply. But the water's being drawn out 50 to 80 millimeters above the bottom of the storage, so we're nowhere near.
It's about, right, 4 to 6
Yeah.
inches. Just
Yeah.
translating for my non-metric.
Yes, yes, that's right. You guys are imperial, so 4 to 6 inches. Yeah.
Yeah,
So
let's be bilingual as
yeah.
a Canadian.
So anyway, and it's sitting there in that storage, moving slowly around, contacting the other drops of water and contacting either the sludge on the bottom or the biofilms on the side, and it's slowly being cleansed because the quality of that drop of water improves in time in the storage because of this process that's going on. Then we want to use water. So the pump turns on and say the drop is drawn through the pump. As the drop comes through the pump, it actually encounters a sudden change in pressure, which eliminates a lot of the bacteria in the drop, if any bacteria is still remaining, because bacteria don't like changes in pressure, particularly sudden changes in pressure. And then as it's drawn into the pump, there's a 30 micron filter to protect the pump. That means any coarser sediments or any quite fine sediments, when you think about it, are actually also not drawn through the pump. So then that goes to supply, say, for watering my garden, just straight out the tap and away we go. If it goes to my kitchen sink for our drinking water and cooking tap, it passes through a 1 micron filter, which will remove anything else. So it's what you guys call ultrafiltration, but it's got carbon filtration in it too. And it's got a silver element as well. So silver is pretty deadly to bacteria as well. And I love that cartridge because they last about a year, don't cost much. And the manufacturer rings us in a year, said, have you replaced your cartridge? You're ready to replace it. And they sent us another one and we put it under the tap. So easy peasy. So then say if we're using hot water, that drop of water goes into the hot water system and it changes temperature to, say 55, 60 degrees C. And as we know, in the domestic hot water system, it eliminates any residual harmful bacteria that may be in that water. So if on our farmhouse we've got an instantaneous hot water system that applies a lot more instant heat energy to that water drop, so it almost completely destroys any sort of bacteria in the water because it's really applying 150, 200 degrees C of heat energy to that drop of water in a very short time. And that's my system. So
what about hand washing basins in the bathroom sink?
all fine.
No additional filtration because you said it's your kitchen sink that you have the 1 micron filter directly
Yeah,
at the sink.
washing hands and bathroom basin and so on is perfectly fine. But to remember that drop has been through an entire treatment train that I've described, including through a pump that with the sudden application of energy is destroying a proportion of any bacteria in that water. I don't have any cows or humans defecating on my roof, so the likelihood of the type of contamination we're worried about is low. If it's bird poo, by the time it gets through that system that I've just described, well, it's just highly unlikely any bacteria from birds would also get through that system because it's completely sealed and designed properly. And remember, there's a 30 micron filter, then the pump after all these other processes. Say it's Campylobacter that's got into the storage because it's got through all the other processes, which is highly unlikely. It's going to be at the water microsurface layer at the top. It's going to be still there. It's not coming down at the bottom of the storage where there's no oxygen, which that bacteria needs. Same as Legionella, no oxygen, no warmth. It's not going to be down at the point.
So do you think that sometimes some of the concern is driven by possibly tests. Say someone, scoops off the top layer of the rainwater harvesting tank and sends that in for testing, and then comes back and says, oh my, we have huge cause for concern because we found this, and this, and that, surface layer of the water tank out, and taken all that out of context of the existing natural treatment train that occurs. And
You've actually you've articulated the main reason for some quite misleading academic publications around the world about rainwater harvesting. I was in a position to review most of them, and almost always they've tested it in the worst possible place.
like taken the sludge layer and said, oh, there's 30,000 times the lead quantities in the sludge layer than really what's recommended, right? And so, you read something like that and it becomes really concerning about, oh wow, this rainwater harvesting system has this really elevated lead concentration in the sludge of the rainwater tank. This is really serious, and we need to treat this rainwater system very cautiously, right? And so again, same idea, right?
Same idea, but the sludge one is where some key agencies in Australia have been, dare I say it, a little naughty. Couldn't find much in the water column, so they've actually emptied the tanks, and this is our CSIRO, and they've left a small amount of rainwater in the bottom, mixed the sludge up with the rainwater, and then sampled it and said, hey, there's 80,000 times the concentration of lead there. So they've completely disturbed the process to get that sample, so it's not realistic. What our research has shown is the sludge has got polysaccharides in it. That's what biofilms used as very sticky substance that holds itself together, and it holds everything else in, like, bits of metal and sediments and so on. And they're very sticky. And unless you strongly physically disturb it, contaminants drawn into that sludge stay there. So it's a really good treatment method. So for mainstream water industry people, think of the trickling wastewater filter that uses a biofilm sludge to draw out all the contamination in wastewater treatment. So it's very successful method of treating wastewater. So that's what the sludge does. So the two major sources of concerns about the quality of rainwater is people are scooping into on the top, and people are actually sampling the sludge rather than the actual rainwater. It's a good point, Michelle. So be aware of that. Test your rainwater at the point of use if you're going to test it.